Okay, for our next video, we're going to be working in Mathematics 3. Whoops, let me get my pen here. Mathematics 3, rational functions, and we're going to be working on discontinuities and zeros, asymptotes, undefined points, etc. So let's go ahead and get started with our first question. Our first question here is find whether there's a zero or a vertical asymptote or a removable discontinuity, which in our program is called a hole in your book, but discontinuity is another way to refer to it. So how am I going to get this? First, I'm going to factor completely. So this is going to be I'm going to look for two numbers that multiply to negative 14 and add to 5. So I've got x plus 7 times x minus 2, and then let's see, let's factor the bottom. I see 3 and 7 there, so I'm going to get x plus 7 and x minus 3. Check that I did that right. Okay, so here at the bottom here I've got x plus 7 as a common factor. So that corresponds to x equals negative 7, and it's going to be a removable discontinuity because when I cancel those out, I don't have negative 7 anywhere. But it is an excluded value. Remember that we learned that word. Excluded value. It can't be in our domain, okay? And next I've got x equals 2, so that's going to make this top part 0 here. So that's going to give us a 0. And then x minus 3 is going to make this denominator 0, so that is going to create a vertical asymptote for us. Let's take a look at the next problem. And again, we're going to find these zeros and vertical asymptotes and removable discontinuities. Whoops. Okay, and your book calls those holes. Okay, so I'm going to factor. And I'm going to factor this out as x minus 8 times x plus 5, and this one over here as x plus 8 squared. So you can see this bottom, it looks like the 64 is 8 squared and 16 is 2 times 8. All right, we did all of this back. You should have done it last year, or we did it in our review unit. So let's see. Let's first look at our first number here. X equals negative 8. That's going to set this denominator equal to 0, and so that's going to give us a vertical asymptote. Next, x is negative 5. That's going to set our numerator equal to 0, so that's going to give us a 0. And x equals 8 is also going to set our numerator equal to 0. So that's going to give us a 0. Let's look at our next set of numbers here. And again, I'm going to factor x plus 11 times x minus 1. And over here, we already have x minus 11. We don't have any common factors, see? So we're not going to have a removable discontinuity. We don't have anything in common here, so we're not going to have a removable discontinuity. X is negative 11. When x is negative 11, that's going to turn our numerator into 0, so we're going to have a 0. When x equals 1, that's going to turn our numerator into 0, so we're going to have a 0. And when x equals 11, that's going to turn our denominator into 0, so that's going to be a vertical asymptote. Let's look at our last one. I'm going to factor here. I have x plus 5, x minus 3 over x plus 5 squared. And you can see that and I've got a common factor here, but once I cancel those out, I'm still going to have one x plus 5 left over. So this is not actually going to be a whole. This is going to simplify to x minus 3 over x plus 5. Okay, and that x plus 5 is still an excluded value even in here, so we just simplified it. Okay, so that's all we have to worry about. We only have to worry about this one right here. We didn't change any excluded values. Okay, so we don't have any removable discontinuities. So x equals negative 5, that's going to make our denominator 0, so it's going to be a vertical asymptote. And x equals 3 is going to make our numerator 0, so it's going to be 0. Hope it's clear how to do that set of problems. If you need any help, go ahead and contact me. Good luck.